Alright, so we have been doing a lot of place value thinking in relationship to decimals and where they fall on the number line. Today we're going to move into the big question of what is a certain number closest to. So if you're looking on your paper along with me, we're going to start up here on this number line. And when you first glance at this number line, you may be a little confused because we have 1 7/10, 1 8/10, and then in the middle we have 1 71/100 all the way to 1 79/100. So what typically is confusing to some of us when we look at this is how in the world is 1 71 or 1 76 in between 1.7 and 1.8? Because most of us are looking and seeing a 7 here and an 8. But strong math thinkers are going to know that these are decimals, and whenever we think about decimals, we always want to think about money. So the problem with this number line is before we can address what is 1.76 closest to or 1 76/100 closest to, we can obviously see that it's closer to this 1.8, but we really want to understand why. We want to think money. So this does not look like money yet. Why? Right, it does not have 2 past the decimal. Money has to have 2 past the decimal. So this is really a $1.70, and this is $1.80. Oh, see, now things make a lot more sense when we look at our number line. We can see 1 70, 1 71, 1 72, all the way down to 1 80/100, or $1.70 down to $1.80, as I like to think about it. So to this question, what is 1 76/100 closest to? Well, if I'm looking on my number line, if this is my starting point, it's going to take 1, 2, 3, 4, 5, 6 steps to get to this number from here. Whereas if I look over here, it only takes 1, 2, 3, 4. So it's clearly closer to 1 8/10 or 1 80/100 if we think money. Now we want to write the way they gave it to us, which is 1 8/10. But of course I've shown my thinking here by making it look like money. Now let's take a look at a couple more examples. So let's look at this example here. We were given 1 26, and we can first go find it on the number line right here. We want to circle it, and we want to think about what number is it closest to, 1 2/10 or 1 3/10? Now we run into the same problem here of how in the world did we go from decimal 2 to decimal 21? That's again why it is so important for you to remember that when we work with decimals, we always think money, money, money. And when I go to the grocery store, nothing is labeled 1.2. It would be labeled $1.20. It's always got 2 past the decimal. So this one over here doesn't look like money yet either. This would be $1.30. Now our number line makes a whole lot more sense. $1.20, 21, 1 22, 1 23, all the way to 1 30. Now, when I glance at my number line, it's very easy to see that this number is again closest to the 1.3. Now, whenever we're talking about which number something is closest to, what we're actually doing is rounding. And I know that you all have learned lots and lots of rounding strategies in the past, and we are going to grasp on to one this year. And if you have a rounding strategy that works for you every single time, feel free to use it, but I am going to show you the way that I prefer to round my numbers on this video. Let's take a look at a couple more examples before I show you mathematically why we can prove, or how we can prove, that this is closest to 1.3 without drawing out a number line. So let's go down to 3.49 or 3 49/100. Again, first I want to make this all look like money. And then I can find the value 3.49 here. And I can see very quickly, boom, it rounds to 3 5/10 or 3 50/100, depending on how I want to think about it. Then let's jump down to 1 3/100, and we want to find it on the number line first. And we want to say, who is it closer to? It's only 3 away from this number, and it's 7 away from this number if I were to count how many dots it takes to get there. So clearly it's going to go back to 1 whole, or 1 decimal 0. And again, I can think of this as money, $1 or $1.10. If I have $1.03, I'm much closer to just having $1. I'm not closer to $1.10. So let's go ahead and look at one more example on the number line. And this one I want you to really look at and think about on your own for a minute. We've got 2.65. And let's see, if we're thinking money amounts, this would be, is it closer to $2.60 or $2.70? That way we can make sure our number line makes sense to us. 260, 2 61, 2 62, right on along. So now, we're going to run into a problem here. What is 2 65 closest to? Let's see. If we go back, it takes 1, 2, 3, 4, 5 to get here. And it takes 1, 2, 3, 4, 5 to get here. So, we are running into a situation here where we are directly in the middle of two numbers. Now, I like to relate this to going to school and forgetting my homework. So, here you are here you are at home, 2.6 or $2.60. And if you've gone about this far or this far and you're like, oh, I forgot my homework, it's not too late. You could turn back and grab it real fast. So you could round down to 2 6/10. If you've gone this far, you're still, you're pretty close. You could still grab your homework and run back to school. Once you get about halfway, you've really you're like, I'm halfway to school. I'm not going to go all the way back here to get it. Once you've at least made half the journey, you're just going to go ahead and continue on. And so our rounding here is once we get at least halfway, and we'll talk about how we know it's halfway in a second, you're just going to go ahead and bump up to the next number. So this would round up to 2.7 or 2 7/10. Now, let's think about how we knew this was directly in the middle. We were at 2 6/10, and we know with tenths we're thinking about dimes, so 6/10 would be 6 dimes, 6 10-cent pieces, which gives us 60 cents. Over here we've got 7/10, which would be 7 dimes, which will give us 70 cents after our decimal. And we should know that once you look at this place here, once we get to the 5, we are directly in the middle because we have a base 10 counting system. That means that once we get to, everything is based on the number 10, so 5 is always going to be directly in the middle. Now, some of you were probably able to solve this last one using your rounding rules that you have learned in the past. So let's just take a quick look at how we know, or how we can prove mathematically that these numbers round to whatever we wrote in our boxes over here. So, essentially what we are doing on this paper is we are rounding to the nearest tenths place, because they were asking us, what does it round to, 1.2 or 1.3? Since our answer stops at the tenths place, we knew that's what they wanted us to round to. So we took this number, and when we round in 5th grade, most of us like to underline the digit in the place we are told to round to. We were told to round to the tenths place. Is it going to be 1.2 or 1.3? We box the digit to the right, or the following digit. And then we use our rules of, did I get to the halfway point or not? So, up until this point, 0, 1, 2, 3, and 4, all of those are our weak numbers that would allow us to round down to 1.2. Once you get a 5, 6, 7, 8, or 9 in the box, then these are our strong digits right here. These are our strong digits, and they're going to make our tenths place grow or increase by 1. So what essentially it did is our 6 bumped that 2 up to a 3. So you always want to use your box to determine what's going to happen to the digit we underline. So if we go down to this other example, we're rounding to the tenths. We either want to stop at 3.4 or 3.5. Now on the number line we could see it's going to stop at 3.5. Let's find out why. We underline the 4, the tenths place. We box the digit to the right. That 9 is a strong number. 5 or more is a strong number, so it's going to be able to increase that 4 to a 5, and there's our rounded answer. Down here, we are going to underline the 0 because it's in the tenths place, box the 3, and 3 is a weak number. Any of these are our weak numbers. So since it is a weak number, it is less than 5, it is going to round or just leave this digit alone. So it's just going to be 1.0. And then the box digit and everything after it just goes away. So then finally, the one that we were a little tricked on, well, we weren't really tricked, we had to do a little extra thinking. We underline the tenths place because we know we're either going to stop at 2.6 or 2.7. We box the number after it, and because this number is 5 or more, it can increase what we underlined. So it increased that 6 up to a 7. So to show it is closest to a 2.7 on the number line. So we basically got some steps here for our rounding. Our basic rounding steps is that we want to underline the digit we are told to round to, and then we want to box the number after it, or box the digit after it, underline, place, told to round, box the digit after it, and then you're going to rewrite the number until the decision line, and on that decision line you have to make a decision based on the box that comes after it. So I can show you a quick example. Use the box, and we're thinking, is it 0, 1, 2, 3, 4? Is it going to stay the same? Or is it 5, 6, 7, 8, 9, and it's going to increase? So, to use these steps really quickly in action, if I was told to round to the hundredths place, I would of course underline my hundredths place, box the digit after it. I would rewrite the number until the decision line. So I would rewrite 4.5. Now I'm on that decision line. I have to make a decision. And my decision is going to be that this 6 is going to cause it to increase. So instead of being a 1, it's going to go up to a 2. Everything else is gone, and I am done. And that's it.